For today's lesson, we're going to review and mix all the factoring types that we have worked with. And we're also going to think about difference of two squares. So for question A, notice the directions say use GCF factoring. For GCF factoring, you want to determine the greatest common factor. I'm going to factor out a -7 for this problem. The leftovers will be your positive 2x minus 3. So the first term is your GCF, and the second part, this is your leftovers. In our directions here, determine f of -1. So we're going to let x equal -1, figure out the answer. For our second type of problem, we're going to do factor by grouping. Count the number of terms. You see 1, 2, 3, 4. Because there are 4 terms, factor by grouping might be our best way. So we're going to put our two groups together, look for a GCF for these two groups. So I have left with x squared times x minus 3. Now the next group, notice the negative in front of the 5. I'm going to factor out -5, and then I'm going to be left with x minus 3. The next thing we notice is that both of my groups have an x minus 3, so I'm going to write x minus 3 as my GCF for those two. And then I see I have x squared minus 5 remaining as my leftover, so x squared minus 5. Now when you find your y-intercept, just remember that you're going to let x equal 0. And once you let x equal 0, you will find that y-intercept. The third type of factoring that we've been practicing is trinomial factoring. You will see that you have 3 terms, and your terms are written in descending order. So when you have 3 terms, you're going to draw 2 sets of parentheses. Figure out x squared is x times x. We're going to fill those in. There we go. And then we have 5, but it's not just 5, it's -5. But 5 is 1 times 5. That minus sign means that we must subtract. And what are we going to subtract to get? A positive 4. The only way that will work is if we have -1 plus 5 to give us a positive 4. And we know with the trinomials, it's in our best interest to check our middle terms to make certain we get that positive 4 we were looking for. -1x plus 5x does give us the middle term, and we know we have factored well. When you're determining the roots, that means you're going to let f of x equal 0, or you're solving for each one of our little factors. So we want to know where x plus 1 equals 0, and x minus 1 equals 0, and where x plus 5 equals 0. Now we have a new type of factoring. This new type is called a difference of squares. We know that difference means that there's subtraction involved, and squares means that we have perfect squares. So one example that you see is x squared minus c squared. So x squared, when we factor x squared, we get x, and when we factor c squared, we're going to get a c and c. But think about this for a minute. We want to be able to subtract and get no middle terms. So when we factor the c squared, we're going to write a -c and a positive c, so that when we check our expressions, we'll get -cx plus cx. Notice there is nothing left for the middle term. So this is your difference of squares. So multiply your first answer. Let's just see what happens. X times x is x squared. Distribute again. We get a plus 2x. Now we're going to distribute -2 to both terms. We get -2x and a -4. The middle terms have always canceled out when you were multiplying at x minus 2, x plus 2. And you're left with x squared minus 4. Now we're going to classify this answer. Notice it's a binomial. And this binomial is of degree 2. So if you have a binomial of degree 2, you might recognize it as a difference of squares. Now this new factoring method will not work unless there is a difference of squares. So let's look at example 1. We're told to factor. Do you notice that there are 2 terms in this problem? The 2 terms. All right, now look, is there a difference? So you're checking for patterns. I do see a minus sign. And do you see perfect squares? If you do, draw 2 sets of parentheses. Take your n squared, and we know that that will be n times n. Think about 16. 16 is 1 times 16, 2 and 8, 4 and 4. I want to subtract to get 0? Well, the only numbers, factors I can use are -4 and +4. So my two factors for this problem are n-2 and n+2. So we have a difference of squares and we factor it n-2, n+2. Let's look at our next problem. Okay, so I once again recognize that I have a binomial, and when I check it out, it's definitely a difference. And are those squares? Does 9x squared have a perfect square? It sure does. 3x times 3x makes it a perfect square. And 25 is 5 times 5. So this is a difference of squares. So when we write our factors, we're going to write the 3x, the 5, and the 5, but we need to have opposite signs so that when we check those middle terms, they will cancel out. So we now have our two factors, 3x plus 5 and 3x minus 5. Looking at example 3. All right, so this is solving. Now, we know that when we solve a polynomial expression, in this case a binomial, with a difference, that it needs to be set equal to 0. Look at that. It has been set equal to 0. So since it's a binomial difference of squares, we're going to draw two sets of parentheses. We'll write x times x, and 4y squared is 2y times 2y. We're going to put a plus and a minus so that we get the pattern for the difference of squares. Now, since this is a solving problem, we take x plus 2y equals 0 and x minus 2y equals 0, and we solve x is negative 2y, x is positive 2y. You have your two solutions for this difference of squares. All right, now you have some problems to try. Come back in a few minutes and check through a few of the answers. So as you check through your answers, number 5 has no factors because it's a plus sign. Number 11 has no answers because when you move the 121 over, there's a plus sign. And of course, number 6 and 12 were a bit sneaky because they were not difference of squares at all. They were GCF problems. So now you need to recognize what type of factoring you're working on. No matter what, you should try the GCF first. And if there is no GCF, then count your terms. Do you have 2 terms, 3 terms, or 4 terms? Depending on the number of terms and the structure of the problem, you're going to choose a different pattern for your factoring. So for your lesson practice, you're going to write GCF, difference of squares, trinomial, or a grouping, GR, to tell what type of factoring it is. Afterwards, you should actually do some factoring. So picking through a few of them. Number 5 has 1, 2, 3, 4 terms, so this is a grouping problem. Now, as I'm looking at number 11, I see 1, 2, 3 terms. It doesn't have a GCF, so this must be a trinomial. And let's see here. Oh, question 4. Notice both of them have m squared. This one is a GCF problem. You want to get the m's out of there. Another one that might be a little bit more daring for you. Number 16. This one has a GCF. Do that first, and then you might even see a difference of squares. So there's 2 things you're going to have to do for number 16. I bet 18 is very similar. But number 22, I see a difference of squares with your 1 minus x squared. And for question number 19, I see 1, 2, 3, 4 terms. That should make this one a grouping problem. So go through, make certain you understand how to do each of these problems.